I think many of you are familiar with Zyte's AI scraping technology. We had a great workshop on it yesterday morning. But I've been quite looking forward to sharing some of the impact that has had on our own data business, how it's changed, how we gather data from the web, and maybe share a few more details about how it works. So I'd like to welcome on stage Iain Lennon, our Chief Product Officer, who's going to talk about this.
Thank you, Shane. Am I on? Yes? I think I'll take the lead from Joaquin. Hi, I'm Iain. I lead products at Zyte. Today, I'd like to talk, as Shane described, I'd like to talk about how AI is allowing us to transform our own data business. But to be specific about that, it's allowing us to solve some specific needs of our customers that we've not been able to meet before. And our customers tell us they've not been able to find solutions for before. And that's what we're finding really exciting about AI. But it's been a journey. It's been a journey that at times has been hard for us. It's been a 4-year journey. And I'd like to share that with you, to share what we found challenging, what we've been learning, what we're continuing to learn. But first, let me put some shape on what I mean by our data business. Zyte works with 2 types of organizations, and we put them into 2 groups. The organizations who need web data and they wish to own the means of gathering that data. So they employ teams of web scraping engineers, and for them we provide software. And we have other organizations who wish to work with web data, but they do not regard the gathering of that data as core business. And so for them, we have a professional services division who uses our own software, who writes code and conducts QA. So for these businesses, we can provide data. And that's the group I'm going to be talking about today. But I touched on some specific needs that we've previously been struggling to meet, or organizations like this have been struggling to find answers for. And what do I mean by that? Well, let's take an example. Let's imagine all of us here are working for a brand analytics business or digital shelf analytics, and our clients are brands. And what are we doing for them? We're providing insight on their brands, on their competitors, on pricing, on shifts to market landscape. And so what data do we need to meet that need? We need data from the major e-commerce sites and categories from those sites. And the volumes may be high because we're taking data from multiple clients from those major e-commerce sites. But then we're taking data from brand sites. And these may be specific to our individual clients and the categories that they're in, be that pot plants or PCs or pet food, specific sites on a per client basis or on a per category basis. And here the volumes may be much smaller because it may be for a specific set of SKUs and specific numbers of clients. Now, overall, I may have needs for specific data points, and that, again, might be by segment. So for our PC clients, we might need GPU brand or clock speed or hard drive size, and that's non-negotiable for these clients. Or for pet foods, categories of animal, age of animal. And overall, the quality of data has to be very high. This is what we run our business on. And the combination of these needs is challenging when we go shopping. And when are we going shopping? When we get a new sale. We've got a new sale. But this one is not big. Let's say we've got a sale of 50K. And on this occasion, we need to add a new category to an e-commerce site. We need 15 more brand sites for this client. Again, we've got specific data points. Let's imagine it's pet food. And we need our high quality again. And so we go looking for solutions for this data set. But wherever we go looking, we see challenges. So is there ready scraped data in the market that fits this shape? Not really. Is there data from the major e-commerce sites? Yes. Has it got my specific categories and products? Maybe. Has it got the specific data points I need for this segment? Probably not. Can I find the brand sites that I need in pre-scraped data sets? Probably not. Not when I get past the top few popular sites. So what do we try next? We ask someone to build a data feed for us. Okay, now we can get everything we need from the sites we need and the data points we need with contracted quality. But there's labor involved of writing spiders for us. And we're going to be charged for that labor, and it might be $1,000 plus per site. So for my 15 sites, I could be talking 15, 30K of cost. For my 50K deal, that isn't looking so exciting. This is now challenging. The labor cost of that kind of horizontal scale with modest volumes and therefore modest revenues, this is getting very challenging for that kind of supply. So, okay, am I now being forced to gather data myself? I didn't regard this as core business, but am I forced into this? Okay, so I need to acquire the kind of esoteric skills around web data, like anti-bot or compliance. And how big does my team need to be that I can add 15 sites at the snap of a finger when I'm maintaining the sites I already have for my existing clients? So overall, this is a combination of needs. I need multiple sites, long tail sites. I've got specific segment data point needs that are non-negotiable. I need high quality. The volumes from some of these sites are low, and therefore the revenue is modest. This overall need structure is not well met in the market. This is what our clients tell us. And what this is pointing to is high quality web data with these kind of freedoms of choices does not scale easily. And this is a problem that we are determined to solve as a business who provides data. And it's a problem that we believe that AI should be able to solve. And we've been working on this for 4 years. But we found it tough at times. And why? Because it is a combinatorial problem. And that's kind of revealed in the structure of the sentence. There's more than one clause in here. There's several goals that we're needing to solve here. Can we give data from any site, not just a top 20? Can we contain the labor cost of accessing new sites so that you can add multiple sites, even when there's modest volumes from each site, and it economically still makes sense? How can we ensure that quality remains high, that we can allow any data, that there's freedom over schema for these data points that are needed for specific segments or use cases, but that we can keep records affordable? And this is not just a list of goals, these interact. We've all seen the triangle of time and cost and scope. We've got a few more points here because there are trade-offs. The kind of approaches that might bring down the cost of setup might drive up the cost of records, generative approaches, for example. Or approaches where I want freedom over schema might drive up the cost of setup because I've got work to do to extend that schema. So these goals are battling against each other. And as we've looked at AI, we've found there's not one single paradigm that solves all of these trade-offs. Rather, we need to look at multiple paradigms and apply them selectively so that we can make this picture work. We've got to apply a picture that we're starting to see called in the market composite AI. And this is taking a multi-paradigm approach. And okay, simplistically, I'm grouping them here of supervised AI for structured contexts, and some approaches for less structured, generative AI, or even custom code. And for us to be able to apply these selectively, we need to decompose the problem. We need to understand what parts of the problem are kind problems versus wicked problems, are structured problems versus unstructured problems. And when we look for structured problems, the first place that we see them is in common schemas. And this offers us insight not just on the data set or the schema, but on the groups of sites. Because we can characterize entire sites or families of sites by their schemas. There are long lists of product sites, very long lists of product sites. There are lists of job sites or article sites. And in doing so, we can characterize large proportions of the internet in this way. Now, this is our product schema. This was inspired by schema.org. We didn't make this up. It's about 30 data points. It's the kind of data points you would expect for a product. The title, the price, the tax, sale price, stock keeping unit, GTIN code, description, and so on. And this is the kind of structured context that's well suited to supervised AI. And we've been developing models for supervised AI since 2020, for 4 years. And it works really well in this kind of structured context, where the data's in the structure of the page, where the title's in a div and the description's in a div. That kind of well-structured context. And in those environments, it's really fast, and it's accurate, and it's cheap. It's cheap enough that it can run on every page. And so it's not breaking when layouts change because it's applying that reasoning on each page. It's finding the data elements, even if they move around the page. Let's have a quick look at that. So for those of you who were in the workshops yesterday, you would have seen Adrian speaking about this. Let's do a quick crawl. We'll look at a category of video game. We want to go into the individual pages, pick up the right prices, the current price, the standard price. And so here we're going to apply some config for our supervised machine learning. We're going to give it the category URL from this site and paste that in and give it a few basic parameters, set a crawl depth. And we're going to pick a crawling strategy so we can get this up and running. And once this is going, I've shortened it a little bit for the video. We've got some results coming out. When we go into that, we can see all the data. This has picked up all the data from the page, and it's normalized it as this comes down. It's normalized it to the schema. And so we've got that full data schema that we saw on screen a moment ago. And as we see further down, it's picked up the different prices, like the current price and the standard price. And I talked about groupings of sites. We've got a few of these models. The percentages we see here are the proportion of demand we have in our data business this year of customers asking us to gather data from sites. So this year, it's about 60% product data. Overall, between these models, we've got about 80% coverage. We've had product data live first, so we're just bringing some of the others live now, and we'll continue to look for more models so we can extend that 80%. Quality has been a big issue for us. Now, I described that we've been developing these models for 4 years. At first, it was the quality of the model. But if we speed up engineering, we're just moving the bottleneck to quality and the assessment of quality. So we've had to automate the assessment of quality as well. So can we create monitoring and alarms around the confidence data that's coming back from the model? Yes. What if that confidence data is misplaced? This year we've been developing large language models to do more human-like quality assurance, to take samples of pages and do more reasoned assessment on those samples, so that when we discover defects, we can then apply a process of applying hinting to individual sites. It's a quick process for us, a point and click. Now that's the price without tax. So we can ensure that a given model works very accurately on a given site. If and only if we still need further overrides, yes, we can write some code. In order that we can guarantee that quality, we can stand over the quality for our clients. But clearly we want to contain that for cost and for time. Cost, yes, has been a big factor for us. The first versions of these models require browser rendering. So on a like-for-like basis, when looking at sites that wouldn't otherwise need browser rendering, when we were extracting with Python, the cost was about 10x. And so this was niche usage. But since we've been able to make the models work successfully on raw HTML, we've brought that cost way down. It's now comparable to Python or close to Python. And that's unlocked our ability to use it on everything. And this is changing our way of working. So previously, when a client asked us for data from a new site, we would solve the anti-bot problems with software, but then we would write spiders on top of that to do the crawling and the extraction, and so there was a labor cost. That might be 20 to 25 hours a site. Now the way of working is more of that job is done by software. We have a template sitting on top of software that we configure, we can conduct QA, we might need to write a small amount of code for the quality, and so on average that's getting us to 3 hours per site instead of 24. And that's a low enough number that we can give it away. We can regard it as a cost of sale. And so now we can offer, it's not quite any site, it's about 80% of the sites that we're asked to look at, but many, many sites, hundreds of thousands, millions of product sites that we can now offer free of charge. This is something we've just been able to do since the summertime. And so we can show that to people. We can say, hey, stick in any product site you can think of, take a look at that. We'll show you the cost per record. You can have a look at some samples, have a look at the data schema. This is meeting your need. We'll give this to you with no setup cost. We'll just charge you for the cost of records. But yes, as you can see on the top right, this is standard. So this is where we're saying to people that standard schema I showed you earlier, we'll give this to you. It's being run by Supervised AI with no setup cost. And a lot of the time, that's great. It's not great all of the time. So I approached, when we started being able to do this in the last few months, I started approaching our existing product data customers and said, hey, do you have scenarios where the cost of setup, the labor charge for setup, is preventing you from doing business? And many of them said, yes, we do. And I said, okay, in those circumstances, when you can't otherwise meet that opportunity because the economics of the labor for all of those sites doesn't make it work, would you take our standard schema if I can give that to you with no setup charge? And they said, let us think about it. Because it created friction for them. It would force a change in engineering pipelines and their own products for their own customers. And some of the time, it was just non-negotiable. If they had customers who needed data points for PCs or pet food, it was non-negotiable to not have those data points. And so they had to say no. So in these circumstances where standard is not okay, how can we meet that need? And this is where abilities around less structured, around the wicked problems come in. So there's two approaches here: custom code, the work of engineers, or of generative AI. These clearly both have more reasoning than supervised AI. but their cost structures are very different to each other. Custom code is all fixed cost oriented, so it's the effort of writing code and maintaining that code, but the volumetric cost, the variable cost of running that Python is very low. With generative AI, the reverse is largely true. The effort of setup and maintenance is negligible, but the record cost of generative AI is much higher than Python. And so the cost structure here is very different. They both have higher costs than supervised machine learning, but in a different way. And so we need to apply them selectively in the right context. For these e-commerce sites, small number of sites, very high volumes, this is where custom code wins that equation because it's fixed cost oriented and variable cost are low. In the horizontal scaling, multi-sites, perhaps with smaller volumes per site, but I need to add many of them, this is where generative wins because it's all about low fixed costs. And so we're applying these selectively in context. But let's start with custom code. Scrapy is the most widely used scraping framework in the world. The template that was running that supervised machine learning is a Scrapy template. It's open sourced. And so it's trivial to then fork that, open that, add a few lines of code, and we can override that. On this occasion, it's creating a custom crawl. So instead of saying, give me everything in that category, it's adding a further field to the UI so that I can go into that and add a value to use as a filter. In this case, I only want to see computer games that cost more than $20. And I've done that with a few lines of code. It was very straightforward. And so when that's done, I can run it, and I'll see the results. And OK, it's the same schema on this occasion, but I could have taken the same approach to extend the schema. And this is allowing us to put a much more compelling offer to these customers. Instead of saying, well, it's a binary choice, you can either have supervised machine learning with no setup cost, but it's a fixed schema, or it's anything you want, but we're doing it all custom, and so there's a high labor charge. Instead of those binary choices, this is part and part. This is saying those data points that are delivered by supervised machine learning we can give you with no setup cost, no labor cost, will only charge you to add the custom fields. And so this is often very compelling. And so these are real customers, and these are real examples of data points. Take that top one. We previously would have been writing a spider for 18 data points. Now 17 of those are out of the box. We're just writing a data point we're just writing code for one data point. And so the cost comes down dramatically. And that means I can go back to these customers and say, OK, you can keep the same schema. You can keep the high quality, but I can slash your setup cost. And this time, it's a much easier question with a much easier answer. And this is really changing our experience for these customers. It's allowing them to start saying yes to opportunities they were previously having to say no to. Opportunities that has horizontal scale, where they need multiple sites, where they perhaps have modest volumes per site, and therefore the revenues are modest. Where the labor cost was impeding doing business, this is now allowing that to happen. And so it's changing their landscape. But I have sorted this by the last column. So the nicest one is on the top. And it does go longer. So down at the bottom one, I've got 45 standard data points and 12 custom. We have customers where the reverse is true, where there's 12 standard and 45 custom, or more than 45. And clearly on those occasions, we're still writing a lot of custom code if we're working this way. And so the cost saving of this approach is not so dramatic. It's not so transformative. What can we do here? This is where generative wins. We're working with two generative models. Arguably, BERT is not generative. I'll come to that. Llama 3 is the open source model from Meta. And we host our own copy of that. Why do we host our own copy? When we talk to customers around making use of large language models, some of them were pretty uncomfortable with the guarantees that we could offer about data in and data out and what happens to that. And so we host this ourselves so that we can offer those guarantees. BERT is what you would now call a small language model. So it's less sophisticated, but it's around a 20th of the cost. And so its capabilities are a little bit similar to supervised machine learning in terms of lifting content out of the structure of the page, but with more flexibility over that schema. But it's much cheaper than truly large language models. And so again, we're looking at applying the right paradigm in the right context so we can find the right balance of capability and cost. Again, let's take a look at this. So those of you who were in Iban's workshop yesterday would have seen a little bit of this. He's going to be talking more about this today. Let's imagine I need some data point in the center there around page sizes or format of printer. That was not in the structure of the page. There wasn't a separate div for each of those. It was just in a blob of text. How can I get that out? Well, I'm going to create a couple of custom attributes here with Llama 3. This first one, I'm going to give it some acceptable values. And because this is a large language model with world knowledge and reasoning, it's able to set these kinds of rules. So I can capture that one. I'm going to add one more for the paper sizes. This one's going to be an array. So I want to return multiple items for this. What are all the different paper sizes this printer can return? And so we're instructing this here with a description. This is prompt engineering. We've done our own prompt engineering on top of Llama 3. Here we're creating effectively a prompt within a prompt that we're passing to our own prompt engineering. This is the overall picture of the custom attributes that we've created, and we can run that. And when it runs, we see these additional attributes appearing, like the array for the paper sizes there. But we're also seeing the number of tokens used so that we can monitor and control that cost. Now, the prompts that we created there do not need to be site-specific. There's enough reasoning in Llama 3 that it can take those concepts of find me the paper sizes, find me the category of printer, that they can work on multiple sites. We've got a client for whom we're gathering data from 600 sites, and we're using one set of prompts across those 600. So horizontally, it scales fantastically well. It's not been without challenge. We've had to put perspiration into this, particularly around controlling costs, controlling the amount of tokens that get used. An HTML document is a large document. How can we scope down the portions of that document that are sent to the large language model so that we can contain the number of tokens consumed? These are the kind of challenges that we'll hear Iain talking about. We had to look at compliance. How can we filter out personal identifiable information so that people can use this with confidence? But overall, the picture we have here of taking a standard schema that's satisfied by supervised machine learning because it's well structured, and selectively adding on to that schema additional data points with paradigms that have more reasoning, that have more cost, but are being used in controlled ways, allow us to give people a choice of any data, but with affordable records. And it's a reminder that we can't solve any of these problems in isolation. We have to solve them in twos and threes to understand the trade-offs between them in order that we can meet pragmatic goals. And so we've been applying these different paradigms selectively to decompose the problem. Where is it structured? Where is it a kind problem? Where is it unstructured? Where is it a wicked problem? So we can apply the right levels of reasoning, the right levels of cost in concert, in combination to the right points in the problem. And in doing so, tame the shape of this pentagon. To tame the trade-offs so that we can meet the kinds of needs that I touched on at the beginning of this talk. Around scale, around choice, of site, of data, of cost of setup, of cost of records, and of quality. Now, everything I've shared today, I've been sharing the work of our own data business, but we'll make it available for our software users as well. Some of what I've showed is in pre-release at the moment, but it all will be becoming available for release. I'd like to work with anybody in this room to give you access to that. We can show you how to use it and build your familiarity and get comfortable. Because yes, we'd like to work together in order that we can make quality web data that scales. Thank you. I think I'm going to be joined by a couple of experts.